Hello. Let me welcome all of you to the course on chemistry, which I have noted down as Chemistry 2, and it's the introduction to molecular spectroscopy. In an earlier course, I talked a little bit about very elementary principles of quantum mechanics. This is a continuation of that course, and this is offered through the NPTEL project. Now, let me ask the question, what is spectroscopy? A very simple or a straight one-line answer is that it is the interaction of electromagnetic radiation with matter. Then, what is a spectrum? Spectrum is obviously the object of spectroscopy and the understanding of it, and therefore you see that it's the display of light that is either absorbed or emitted, namely the intensity of absorbed or emitted light by the chemical substance as a function of the wavelength or a frequency. Now, spectroscopy can be both qualitative and quantitative. From purely experimental point of view, spectroscopy is the mother of quantum mechanics. Okay? And it's also the basis for all of chemistry, most of physics, biology, and also has enormous applications in material science. It enables us to verify conclusions arrived at by applying the quantum mechanical principles to the study of molecular properties as proposed by the pioneers in quantum mechanics such as Erwin Schrödinger, Werner Heisenberg, Paul Dirac, Max Born, Niels Bohr, and Albert Einstein, among many others. My purpose in organizing this particular short course is to share with you my enthusiasm as well as excitement in learning such a fundamental course that's the basis for most of molecular spectroscopy and most of chemistry, physics, biology, and material science. We shall have a quick look and also have a focus on how the electric field of the electromagnetic radiation interacts with electric properties of molecules here. And that's called optical resonance spectroscopy. It's the interaction of the electric component of radiation with electrical properties of matter. The other of the electromagnetic radiation, namely the magnetic component of radiation, its interaction with magnetic properties of matter is the subject of magnetic resonance spectroscopy. We shall use for most of our studies the elementary but extremely important concept of resonance. I've just given a small picture here that if we have a very clear and quantitative detail of the energy levels of molecules, and suppose we have two energy levels in a molecule named E1 and E2, then resonance in spectroscopy is the condition when the electromagnetic radiation, which is used to excite the molecule from E1 to E2, has a frequency nu, which matches with the frequency of or the gap between the two energies given by the condition that the energy difference E2 minus E1 is equal to h nu or approximately equal to h nu, the energy of the photon. Okay. This is the condition under which we will study most of our spectroscopic concepts. Okay. The most important thing in a spectrum that we have to look at are three things, namely line positions, line widths, and line intensities. How different radiation energies allow us to understand different molecular properties, that is, different radiation energies sample different molecular properties. These are the most fundamentally important ideas in spectroscopy. The other extremely important thing to remember is that, you see, the molecules are very dynamic and extremely fast moving entities, and therefore for observing a spectrum we have time domains that vary from millisecond 10 raised to minus 3 seconds, usually in the radio wave spectroscopy, which is from millisecond to microseconds, to very, very excited spectroscopy, laser spectroscopy, the time limit of attosecond, which is 10 raised to minus 18 seconds. Thus, you see that molecular time domain and the properties that we study are really varied under the spectroscopic investigations. The last and most important thing before I leave this introductory lecture is to tell you that spectra are fingerprints of molecular behavior. They are quite different for different energies, as I told you, of radiation from radio waves to ultraviolet rays. These fingerprints are also sensitive to the environment. Therefore, spectra offer enormous challenge to the scientists throughout the world in understanding the molecule level details, and I hope to capture some of these in my short and introductory course, and therefore I welcome all of you to this course and welcome you to join the exciting family of spectroscopists. Thank you.